Hello guys, let's talk about the mole concept. So here we'll see the meaning of mole, the various terms that can be involved in mole. So let's begin. What is the mole? A mole can be defined as the amount of a substance that contains as many elemental particles as the number of atoms present in a 12 gram of carbon 12 isotope. The standard unit is called the 1 mole of a substance, and the 1 mole of each of these different substances contains the same number of particles, which are the atoms, molecules, ions, electrons, protons, neutrons, and the others. Now that number, that per mole, has been worked by several different experiments methods, and is found to be 6.0 times 10 raised to 23. This value is what we call the Avogadro's constant or the Avogadro's number, and it is abbreviated as L. So basically, through this Avogadro's constant, uh, it has been worked out to find that each mole has this kind of a capacity. So that's how we get that the definition of amount, that amount of a substance that many elementary particles that are found in an atom are presented by this 12 gram of carbon 12 isotope. Now, why carbon 12 isotope? You see that in the finding this value, that is the Avogadro's constant, is obtained. So this value 6.0 times 10 raised to 23 is obtained through the relation as follows: that the mass of an atom of carbon 12 is 1.993 times 10 minus 23 gram. Now, then the number of atoms present in a 12 gram of carbon 12 is derived as one, since we said that one atom is equal to 1.993 times 10 raised to minus 23 gram. How many atoms will be equal to 12 grams? So if you calculate there, it means if you let the unknown be equal to x, so it will be equal to 12 gram times 1, then you divide by that number 1.993 times 10 raised to negative 23. That's where we get this value 6.02 times 10 raised to 23. And so the Avogadro's number is the number of atoms in exactly 12 grams of carbon 12 isotope. Now, 1 mole of any substance contains as many as the elemental particles as the Avogadro's number, that is the constant. So that's how we can get the Avogadro's number. Moving on, more quantities of different substances. The mass of 1 mole of any substance, its molar mass is the atomic mass or the molecular mass expressed in grams. Why we use mostly grams? Because many of the substances that are used, the example in the chemistry laboratories, are in small quantities. So basically, we use grams. Now you can calculate the molar mass of any substance by summing up the relative atomic weights of its constituent atoms. For example, maybe ethanol, that has this formula C2H5OH. It contains, as you can see from this formula, it contains two carbon atoms, 6 hydrogen atoms, and the one oxygen atom. So the molar mass of the ethanol can be calculated by the molar mass of each one, then the mass of each of these, then you add them. So if there are two carbon atoms, so it will be 2 times the mass of carbon, that is 12, plus here we have 6 atoms, 6 of this hydrogen, so it will be 6 times 1, then plus 16, that is of 1 oxygen atom. So thus we get 46 gram. So that's how you can find the molar mass of any substance, simply by summing up the relative atomic weights of its constituent atoms. Moving on more about the application of a mole concept. Let's see finding the known masses of elements, molecules, or ions to moles. So basically, number of moles you can get simply by dividing mass of a substance over its molar mass. Known volumes of gases at S.T.P to moles. First, you have to notice that the volume occupied by 1 mole of a gas at a standard condition of temperature S.T.P, and has been scientifically determined, and it is found to be 22.4 decimeter cubic. Now, this volume is called the molar volume of a gas. Now, the number of moles of a given sample of a gas obtained by dividing the volume of a gas by its molar volume, which is 22.4 decimeter cubic. So, mathematically, number of moles when using volume will be equal to volume over molar volume. For example, maybe 4.4 decimeter cubic of carbon dioxide gas at S.T.P will be equal to 4.4, you divide by 22.4, that equals to 0.196 mole. Similarly, 2.24 decimeter cubic of neon gas at S.T.P will be equal to 2.24, you divide by this 22.4, which you get 0.1 mole. Let's see the masses of solids or volumes of known gases to actual number of particles. Now, the number of particles in 1 mole of any substance is 6.02 times 10 raised to 23. Now, to find the number of particles in a substance, we use expressions such as capital N will be equal to N times L, whereby the capital N is the number of particles in that substance, small n, that is the number of substances in moles, and the L, that is the Avogadro's constant. Now, this convection requires the following steps. The first one is that convert the mass of solid or volume of gas to moles, and then you multiply the number of moles by the Avogadro's constant. For example, to convert 5.6 decimeter cubic of ammonia gas to actual number of ammonia moles, then change 5.6 decimeter cubic of ammonia to moles, so which will be equal to 0.46 decimeter cubic divided by 22.4 decimeter cubic, which you get 0.25. Then you multiply by the Avogadro's constant to get the total number of molecules. So it will be equal to 0.25 times 6.02 times 10 raised to 23. That will be equal to 1.5 times 10 raised to 23 molecules. Also, similarly, example 1.12 decimeter cubic of hydrogen gas also will be equal to 1.12 divided by 22.4, which will get 0.05 mole, which is equal to 0.05 times 6.02 times 10 raised to 23, that is equal to 3.0 times 10 raised to 22 molecules. Alternatively, can find out the number of particles by converting the given volume to the number of molecules straightforward without passing through the number of moles first. So we know that 1 mole, as we said, equals to 22.4 decimeter cubic of gas at S.T.P. So simply will be equal to 6.02 times 10 raised to 23. So example, if we're given 5.6 decimeter cubic, will be equal to 5.6 times 6.02 times 10 raised to 23, then you divide by 22.4, which you get directly the answer is 1.5 times 10 raised to 23 molecules. Let's see how to find the concentration of solutions. When a chemical substance is dissolved in a given volume of solvent, you can measure the quantity of solute in two ways. You can measure either its mass in grams or its amount in moles. Now, the final volume of solution is usually measured in a decimeter cubic. So when we measure the mass of a solute in grams, we obtain the mass concentration, and that is in gram per decimeter cubic. Now, finding this concentration in a gram per decimeter cubic will be equal to mass of solute in a gram. Then you divide by the volume of solution in a decimeter cubic. Thank you.